Imagine, for a moment, a perfect summer night in 1977. The air is warm, the stars are impossibly bright, and deep in the heart of Ohio, a massive radio telescope is silently scanning the cosmos. Suddenly, a printer whirs to life, spitting out a single sheet of paper. On it, etched in stark black ink, is a sequence of letters and numbers that would baffle scientists for nearly 50 years. It was a signal so precise, so powerful, and so utterly unlike anything ever detected before or since that it was instantly dubbed the Wow signal. But what exactly was it? Was it a garbled cosmic whisper, a fleeting natural phenomenon, or undeniable proof that we are not alone in the universe? To truly grasp the significance of this anomaly, we need to transport ourselves back to a very different time. The year is 1977. Disco is king, Star Wars has just premiered, and humanity is still reeling from the cultural revolutions of the late 60s and early 70s. But beneath the surface of everyday life, a quiet revolution of a different kind was underway: the scientific search for extraterrestrial intelligence, or SETI. For decades, the question of whether we are alone in the universe had captivated philosophers and scientists alike. But without the technology, it remained a philosophical debate. That changed with the advent of radio astronomy. By the 1970s, facilities like the Big Ear Radio Telescope at Ohio State University were dedicated to this audacious quest. The Big Ear wasn't just any telescope, it was an immense structure, covering several acres, with its massive fixed reflectors designed to sweep the sky as the Earth rotated, listening intently for any signs of intelligent life. It was a laborious, painstaking process, requiring dedicated scientists and volunteers to sift through mountains of data. The SETI program at Ohio State wasn't looking for flashing lights or little green men. They were searching for something far more subtle, yet incredibly profound: radio signals that bore the unmistakable hallmarks of intelligent origin. Specifically, they were focused on a narrow band of radio frequencies around 1420 MHz. This frequency is critically important. It's the hydrogen line, the emission frequency of neutral hydrogen atoms, the most abundant element in the universe. Scientists reasoned that any advanced civilization trying to contact others across vast cosmic distances would likely choose this frequency because it's universally known and relatively free from cosmic noise. It's like finding a universal language. The Big Ear diligently scanned the constellations day after day, year after year, mostly picking up naturally occurring cosmic static, distant quasars, or the occasional terrestrial interference. It was a long shot, a needle in a cosmic haystack. Then, on August 15, 1977, something extraordinary happened. Volunteer astronomer Jerry Ehman was reviewing the computer printout of the telescope's data from the preceding days. His eyes scanned the familiar sequence of numbers and letters representing signal intensity. Most were ones and twos, indicating background noise. But then, standing out like a beacon, was an alphanumeric sequence unlike anything he had ever seen: 6EQUJ5. Immediately, Ehman knew this was different. He circled the sequence in red pen and scribbled "Wow" in the margin. The name stuck. Now, to understand why this string of characters was so significant, we need to delve a little deeper into the data. The Big Ear recorded signal intensity on a scale from 1 to 9, and then used letters A to Z for intensities stronger than 9. The 6EQUJ5 sequence meant the signal peaked at an intensity of U, an incredibly powerful signal, many times stronger than the average background noise. But power wasn't the only thing that made it stand out. The signal lasted for exactly 72 seconds, the precise duration that the Big Ear's fixed antenna could observe a point in the sky as the Earth rotated. It had a narrow bandwidth, just 10 kHz wide, which is characteristic of an artificial transmission, not natural phenomena. And most importantly, it was precisely at the hydrogen line frequency of 1420.4556 MHz. This was almost too perfect. It was exactly what they had been hoping to find. The team immediately tried to confirm it. They pointed the Big Ear back to the same celestial coordinates, expecting to redetect the signal to prove it wasn't a fluke. They tried again. and again. For weeks, months, and even years, they returned to that spot in the constellation Sagittarius, near the globular cluster M55. But the signal was gone. It never reappeared. The disappearance of the signal was, in some ways, even more mysterious than its initial detection. If it was an intelligent transmission, why was it so brief? Was it a momentary test? A passing message from a rapidly moving spacecraft? Or, more prosaically, was it a one-off natural event, perhaps disguised in an almost perfect imitation of an alien beacon? The scientific community struggled with explanations. One of the most common natural theories was that it could be an intercontinental aircraft reflecting a terrestrial signal. However, modern research has largely debunked this, as the nature of the signal and its precise frequency make a terrestrial origin highly improbable. Another theory suggested it could be a fleeting natural radio burst, like a pulsar or a fast radio burst, FRB, though the technology to detect FRBs didn't exist in 1977, and the characteristics of the WOW signal don't perfectly align with known FRB signatures. Another intriguing, albeit more controversial theory emerged decades later: comets. In 2017, for the signal's 40th anniversary, astronomer Antonio Paris proposed that the WOW signal could have been caused by hydrogen clouds associated with undiscovered comets. His team even identified two specific comets, 266 P. Christensen and P. 2008 Y1, Catalina Garrod, which were in the vicinity of the signal's origin point in 1977. According to his hypothesis, the comet's relatively large hydrogen clouds could have produced a signal at the exact 1420 MHz frequency. While a compelling thought, critical analysis by other scientists has found several flaws in this explanation, notably that cometary hydrogen clouds are usually much larger and would produce a signal over a wider frequency band than detected, and of a different characteristic. Furthermore, these comets wouldn't have been directly in the Big Ear's field of view at the time of the detection. So if it wasn't terrestrial interference, and the cometary theory has significant holes, where does that leave us? The silence that followed the WOW signal remains its most potent characteristic. Scientists have continued to search that region of Sagittarius and the entire sky with increasingly sensitive instruments. Projects like SETI Home harness the processing power of millions of home computers to analyze radio data, but nothing like the WOW signal has ever been found again. The signal still stands as the strongest candidate for an extraterrestrial radio transmission ever detected. Its properties, the narrow bandwidth, the precise frequency, the powerful intensity, and its transient nature, continue to vex and fascinate. For many, the very specificity of the signal, its wow factor, points to an intelligent origin. It was exactly what you would expect an artificial beacon to look like, designed to cut through the cosmic noise and announce its presence. The fact that it never repeated could mean the source was either very short-lived, or perhaps it was a one-time transmission, a message sent without expectation of a reply, or even a system that had since moved or ceased to function. The sheer improbability of something so perfectly matching the profile of an extraterrestrial beacon appearing and then simply vanishing is what keeps the mystery alive. It challenges our understanding of the universe and our place within it. The WOW signal remains to this day an unsolved enigma. It's an almost mythical event in the history of science, a tantalizing glimpse of something that might be out there, just beyond our reach. For nearly 5 decades, it has fueled the imaginations of scientists and the public alike, a solitary whisper from the cosmos that asks more questions than it answers. Was it a deliberate message, a cosmic accident, or something we haven't even conceived of yet? We may never know the truth, but its legacy is undeniable. It has pushed the boundaries of our search, inspired new generations of astronomers, and deepened our collective longing to understand if we are truly alone. Until another signal, equally profound and perhaps more enduring, breaks through the static. The WOW signal will continue to echo through the silence of space, a persistent reminder that the universe holds secrets far stranger and more magnificent than we can possibly imagine. And who knows what new, wow, moments await us in the vast, unexplored reaches of the cosmos.